Welcome to This Explainer. Okay, I want you to picture something for a second. Imagine we're looking down from the absolute edge of space. Below us is this enormous, rotating supercell thunderstorm, just a massive, swirling beast of atmospheric pressure. Now, imagine we rapidly drop down from that serene vantage point straight into the heart of those dark, rolling storm clouds. We're flying right through towering cumulonimbus clouds, and all around us, these distant flashes of light are illuminating the deep, churning interiors of the storm. It's breathtaking, it's kind of chaotic, and honestly, it's the perfect stage for our journey today. So let's just tackle the elephant in the room right away with this mind-blowing question. How on earth can a bolt of lightning become 5 times hotter than the surface of the sun? I mean, no way, right? It sounds literally impossible. When you see slow-motion lightning light up the whole sky and you hear that deep, rolling thunder, you are witnessing an energy release so intense it completely defies our everyday understanding of physics. But to really understand this and the sheer mechanics of a strike, we can't just look at the flash. We actually have to rewind and look at the continuous, dynamic motion of the atmosphere. Which brings us to Phase 1, the birth of thunderclouds. You know, it's wild, but all this chaos actually starts with something incredibly peaceful. It just begins with the silent evaporation of microscopic water molecules from oceans, lakes, and rivers. Just a gentle upward migration of moisture. But then, convection currents, think of them like a giant atmospheric elevator, force all that warm, moist air upward. As it rises, the clouds puff up and grow into those massive cumulonimbus structures we were flying through earlier. And once you're inside, well, it's not just fluffy white mist. It is highly turbulent. You've got ice crystals, water droplets, and hailstones getting thrown around by violent air currents, just constantly crashing into each other in this relentless, churning mess. And that brings us to Phase 2, the Great Charge Separation. So inside these dark clouds, all those collisions of hail and ice, they aren't just harmless little bumps. Every single time they crash together, they're transferring electrons. It acts exactly like a ticking atmospheric time bomb. As things physically separate, the tension just skyrockets. Because of the weight differences after those collisions, the heavier, negatively charged particles, let's picture them as blue, sink and accumulate heavily at the base of the cloud. Meanwhile, the lighter, positively charged red particles are pushed all the way to the top. And in response to that huge pool of negative energy at the cloud base, the Earth's surface right beneath the storm starts accumulating its own positive charges. The invisible electric field between the ground and the cloud is literally growing stronger by the millisecond. Which leads perfectly into Phase 3, this stepped leader descends. At this point, the tension is so extreme that the air itself, which usually acts as a great insulator, just can't hold it back anymore. It forcefully ionizes into glowing plasma, and this creates what scientists call a stepped leader. Now, this stepped leader is quietly branching downward. It descends from the cloud in these rapid zigzag steps. It's hunting. It's reaching down through the rain and the mist, branching out, searching for the path of least resistance towards trees, buildings, or mountains. And because this is happening unbelievably fast, this complex descending web of plasma is pretty much entirely invisible to the naked human eye. But here's the crazy part. The ground isn't just passively waiting around. The positive charges on Earth actually respond by sending up positive streamers. Imagine these invisible channels of positive charge reaching up from tall objects, like a skyscraper or a tree. All at the exact same time, they stretch up into the turbulent air, just absolutely desperately trying to meet those descending negative charges. And when they finally meet, we get Phase 4, return strokes and thunder. The absolute climax of our explainer arrives in the fraction of a millisecond that the descending leader connects with just one upward streamer. Boom. The circuit completes, instantly triggering the return stroke. This is that blinding white flash of energy that you actually see. And counterintuitively, this brilliant flash is actually traveling instantly upward from the ground, tearing through the sky along that connected plasma channel. All that built-up energy just flows completely unrestricted. And this brilliantly illustrates just how violent this event really is. 30,000 degrees Celsius. When that return stroke travels through the plasma channel, it instantly heats the surrounding air to a staggering 30,000 degrees. And right there, that answers our burning question from the beginning. That instantaneous burst of electrical friction and energy transfer is exactly how a lightning bolt gets 5 times hotter than the surface of our sun. Just incredible. So what does a strike of that magnitude actually produce? Well, that extreme 30,000-degree heat immediately forces the air around it to expand at supersonic speeds. This violent expansion generates immense physical shock waves. That is the rolling, deafening thunder we hear. It's basically a massive explosion in the sky. But there's more to it visually, too. A lot of people don't know this, but most lightning bolts actually pack several return strokes into a single bolt. It's sending repeated electrical pulses along that exact same plasma channel in rapid succession. And that repeated pulsing, that is exactly why a lightning strike seems to flicker when we watch it from the ground. It's a rapid-fire series of pulses, not just one hit. Now let's zoom back out for Phase 5, a global electrical phenomenon. Because when you look at it from space, you realize this massive buildup and release of tension is not an isolated event. Every single second, nearly 100 lightning bolts strike somewhere on Earth, from the peaceful evaporation of water to the violent ice collisions, all the way down to a 30,000-degree plasma channel. This entire sequence is playing out 100 times per second globally. It makes it one of nature's most powerful, continuous displays of electricity, just a perpetual engine of atmospheric energy transferring back and forth. As we wrap up this explainer, you kind of have to marvel at the raw, unseen power constantly churning in our atmosphere. We started with a simple question about temperature, and it unveiled this whole hidden world of invisible branching plasma, upward-reaching streamers, and atmospheric time bombs. So I'll leave you with this provocative thought. If 100 of these violent, complex strikes are happening every single second, what other immense, invisible forces are silently building tension right above our heads, just waiting for the exact right moment to connect?